Hey, how's it going everyone? Welcome to this video. In this chapter we're going to have a look at trigonometry ratios, and to start with we're just going to have a look at right angle triangles. So given a right angle triangle, as shown over here, our first step in most cases is to label it. So let's say we've got some angle given to us here. It might be 30 degrees for example, and we just need to label it, and we've got three sides, either opposite, adjacent or hypotenuse, and they're in relation to where the angle is. So opposite the angle, well, that would be over here where opposite where the angle is, and this side here is adjacent. It's next to the angle, so this would be A for adjacent, and the hypotenuse is always the longest side, or the slope. So labeling triangle always our first step. Moving on, we've got our three trig ratios, and you might remember those as SOHCAHTOA. And that's formed as shown. So sine theta is opposite over hypotenuse, cos adjacent over hypotenuse, and tan is opposite over adjacent. This might be helpful to putting them into a pyramid. And so when you label the triangle, you can pick out which point you have, which point you don't have, or what you're trying to find, and go from there. So for example, if we had, or we're trying to find our sine, it would be our opposite, and that would be divide by h. If we're looking for O, it would be sine times h. Okay, so the base is always going to be times, and if it's on the top, then it's divide. So this line here would be a divide. A lot of this you've probably already come across in earlier years. So we've just got an example here. We've got a right angle triangle as shown. As I said, first step is always label your triangle. So opposite the angle is going to be this side. This is our adjacent, and obviously h. And we're trying to find h, and we've got our opposite, and we don't have a. So if we go back and have a look at those, we've got our opposite h, and so we're going to use this one here. So we say sine theta is going to be opposite over, over h, and put our numbers in. So sine 40 is opposite, which is 10 over h, and I can solve for h as h is 10 over sine 40, and if I work that out, I should get about 15.56. From this one here, I'm trying to find the value of A. I've got a right angle triangle here and a right angle triangle here. At the moment I've got my angle and opposite side, but I have no other side to use. But I can find what this side is here by using Pythagoras. So this is going to be c squared equals 8 squared plus 6 squared. So I'm going to have c squared is going to be 64 plus 36, so c squared is 100, so therefore c is going to be 10. So now we have that as 10. We've got opposite and adjacent, so we're going to be using tan opposite over adjacent. Our opposite side is 12, our adjacent is 10. 12 divided 10 is going to be 1.2. So we can say tan theta is 1.2, so theta is just going to be the inverse tan of 1.2, and using our calculator we'll find that it's 50.19. we're going to have a look at exact values, and this quite an important part of trigonometry unit. And so essentially we start with two triangles as shown here. The first one I'm going to have a look at here. We've got two side lengths of 1 each, and we can work out that square root of 2 by using Pythagoras. Again, our c squared is going to be 1 plus 1 squared. So c is going to be the square root of 2. That's where that comes from. And so these angles are going to be 45 each, because we've got an isosceles triangle. There's not much to say about that, really, at this stage, except when we look at our sine, cos, and tan, and our angle of 45. So these are special case triangles. So sine 45 is going to be opposite over hypotenuse, so it's 1 over the square root of 2. If you want to rationalize the denominator, we can say root 2 on 2. Cos 45 is going to be exactly the same thing. And tan is going to be, so our angle here, opposite over adjacent, so it's just going to be 1. So already we've got three trig ratios that are quite important that we can use later on. The next bit is this triangle here. So we've got an equilateral triangle, side length of 2 on each side, angles of 60. And what we're actually going to do is cut it in half. So if I do that correctly, this angle in here, if we started with 60 and we cut it in half, it's now going to be 30. This side length here was 2, cut it in half, it's now going to be 1. And this side here I need to work out. Again, using Pythagoras, we've got c squared equals a squared plus b squared. Our c is going to be the 2, that's going to be 1, and that's going to be our b that we're trying to find. So I can say b squared is going to be 4 take 1, which is 3. So b is going to be the square root of 3. So that's our other triangle that we're going to use. And now we're just going to have a look at the values of sine, cos, and tan for the angle of 60. And then the same thing, but for the angle of 30. And for 60, for sine is opposite over hypotenuse, so it's root 3 on 2. For cos, it's 1 over 2. And for tan, it's opposite over hypotenuse, so root 3 on 1, which is just the square root of 3. And then same thing for tan of 30, sorry, the angle of 30. So sine is 1 over 2. Cos is adjacent over hypotenuse, so square root of 3 over 2. And then tan is 1 over root 3. Again, I can rationalize that as root 3 over 3. So there's my exact values. So there's 9 there, and these are going to come up quite a lot in this chapter. So it's worth either doing one of two things, remembering your triangles, these two here, and being able to find what those values there we found are, or you can make a table and put those in that you can refer to later on. I'm not going to make the table There's an example in the book if you want to have a look at that. So we've got an example, we've got a ladder which is 4 meters long, leaning against a fence. If the ladder is inclined at 30 degrees to the ground, how far from the foot of the ladder is it from the fence? So we've got a fence here, and we've got a ladder leaning up against it. Makes an angle of 30, and the length of the ladder is 4. We're trying to find how far away from the fence is from the base of the ladder. And so we can use trigonometry. So adjacent and hypotenuse, we're going to be using cos. So cos of 30 is going to be x over 4. So I can say x is going to be cos 30 times 4. And if we look back from our trig ratios, I know what cos of 30 is. It's the square root of 3 over 2. And I can simplify that by cancelling out the fraction. So it's just going to be 2 square root 3. So that's why we use, or how we use, the trig ratios from that last bit. It's so we don't need the calculator all the time. We can use those values. We've got a line segment AB inclined at alpha degrees to the horizontal, where tan alpha is 1/3. So this is example 3. We can draw a right angle triangle. Okay, and that's going to be my alpha value. Now, I've just jumped ahead a little bit, so here's my alpha, and I know tan is 1 over 3, and tan is our opposite over adjacent, so my opposite number has to be 1 over 3, which is my adjacent. And I've got a line segment, and I'm going to call that C. And now from that I can use Pythagoras to work it out. So c squared is going to be 1 plus 3 squared, which is 1 plus 9, which is 10. So c is going to be the square root of 10. The second part of the question says to calculate the vertical height of B above the horizontal through A if the line of AB is the square root of 5. So let's draw a new triangle. And the horizontal, the slope is going to be the square root of 5. I'm trying to find the height, and I've got that alpha for my degree, and I can work that out. I've got opposite over hypotenuse, so I'm going to be using sine and rearranging. So we've just got to go back a slide, just because we need this bit of information before we do the next one. So if we go back to the part A, we found that c was the square root of 10. We're trying to find sine a. So sine of alpha is going to be my opposite, which is 1 over c, which we found was the square root of 10. So now we can use this value here. Sine alpha is 1 over the square root of 10 into the next bit here. Oops, times 1 over, over the square root of 10. And if we do that, we should get 1 over the square root of 2, or if we rationalize, square root of 2 over 2. So that would be our vertical height for the triangle. Next thing we're going to have a look at is the area of triangles. So area of a triangle, pretty obvious, half base times height. You would have come across that before. We're now going to consider this triangle here, and basically it's made up of two right angled triangles put together. And I want to work out the area of this triangle in terms of A, B, and C. So area of a triangle doesn't change, it's still half the base times the height. My base is going to be B, so that's all good. But my height, I don't know what the H is. I want it in terms of A and C. But I can work out what that is, because H is going to be, if I'm talking about this angle here, that's going to be capital C for that corner. As you can see, it's the opposite of how I've labelled the triangle. So A across from A, B across from B, C across from C, and the big capital letters indicate the angle. So H, in terms of this angle here, is going to be opposite over hypotenuse. So we're talking about sine of C is opposite, which is H over A. And so I can say H is actually A sine C. And so over here, instead of H, I'll now have A times sine of C, the angle of C. And I can do exactly the same thing, except for when I'm talking about this angle here instead, it's going to be our base times, and now it's going to be sine A equals hypotenuse, H over C. So H in this case is going to be C times sine of angle A. Okay, so there's two different ways there, just depending on which angle we want to use. So just to finish off, we'll have a look at this example here. So we've got a strange looking triangle, and at the moment we can only use right angle triangles. So if I split that up, I can make two right angle triangles. This angle here should be 60, and so I can work out what the H is by saying opposite over hypotenuse, so sine of my angle, which is 60, is H over 6 square root 2. So H is going to be 6 square root 2 times sine 60. And if we go back to our exact values and find sine of 60, it's the square root of 3 over 2. And just a bit of simplifying. I'll get 3 square root 6. And now I can use that for my area. So A is half the base, which is 5 square root 2, and my height is now 3 square root 6. And if I do that, I'll get 15 square root of 12 over 2. And the square root of 12, I can say, is the square root of 4 times the square root of 3 all over 2. And square root of 4 is 2. So the 2's will cancel, and I get 15 square root 3. So that's my area for the triangle. So that's starting us off for trigonometry ratios. Another example here, as I've shown, where we use the exact value to find our triangle. That's it for now. Thanks for watching.